Class, good morning. Welcome to Rammer Math TV. Today, I'm going to discuss the three-dimensional coordinate system. So let us visit the Geogebra to present to you this kind of coordinate system. Okay, so this is it. This is our three-dimensional coordinate system. So let's start from the scratch. Alright, so this is our three-dimensional coordinate system. Okay, so this red line here is the x-axis. The green line is the y-axis. The blue line is the z-axis. So there's a gray plane where the x and y-axis lie. This gray plane. So we call this gray plane as the xy plane, where we were accustomed to use when we were taught how to plot the points and to sketch the lines and curves in the two-dimensional coordinate system. Okay, so let us focus on this two-dimensional coordinate system like this. Right. Alright, so we know very well in this two-dimensional coordinate system, we know very well that the perpendicular intersection of the y and the x-axis divides the plane into four quadrants. So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Today, as we tackle the three-dimensional coordinate system, okay, I want to tell you that there are two additional planes. Okay, so let me tell you that this xy plane is represented by the equation z equals to 0. Okay, so let's uh, construct the other two planes. So how about if we have x equals to 0? Okay, so this vertical plane here is the yz plane, and this vertical plane is represented by the equation x equals to 0. How about y equals to 0? Okay, so this is the plane xz. So we call this plane the xz, this one, and this plane is represented by the equation y equals to 0. Okay. Because of the perpendicular intersection of these three planes, the space has been divided to 8 octants. Okay, so we have 4 octants above the xy plane, and we have another 4 octants below the xy plane. Each octant is 1/8 of the total space, and each octant can be represented by an imaginary cube whose volume can be decreased or increased in many times, even to the infinity. So we can increase the volume of each as octant. We can increase to the infinity. We can also decrease the volume of each octant. Okay, we can decrease, increase to the infinity, decrease the volume, okay, so on and so forth. Okay, now let us consider the balls. Let's consider the balls. Do you see this red ball floating here? Okay, so that get that ball. So this one is subspace containing the floating red ball. We call this the first octant. How about this violet ball? This one is subspace containing the floating violet ball is the second octant. This one is subspace containing the floating yellow ball is the third octant. This one is subspace containing the floating green ball. Okay, we call that as the fourth octant. This one is subspace containing the floating dark blue ball is called the fifth octant. This one is subspace containing the floating brown ball. We call this subspace as the sixth octant. How about the subspace containing the floating gray ball? Okay, this subspace is called the seventh octant. And lastly, this one is subspace containing the floating pink ball is called the eighth octant. So let us recall. So let's focus above the xy plane. This is the first octant, second octant, third octant, fourth octant. Now let us focus below the xy plane. This is the fifth octant, sixth octant, seventh octant, eighth octant. Right. Friends, if some of you are new to my channel, please don't forget to subscribe and hit the notification bell for more updates. Thank you. Okay, class. Okay, friends or class, do you see this xz plane? So if this xz plane intersects with the xy plane, their intersection results to the formation of x-axis. And if this yz plane, okay, yz plane intersects with the xy plane, their intersection forms the y-axis. And if this xz plane intersects with the yz plane, okay, do you notice? If the xz plane intersects with the yz plane, the result is the z-axis. Okay, so let's talk about the plotting of points. Suppose we have the point 230, 2, 3, 2, 3, 0. That one. So what do you notice about that point? So it lies exactly in the xy plane. Actually, the point 230, this is a point notation in the three-dimensional space, but this is actually equal to the point notation 23 in the two-dimensional system. Okay, so 220 is the point notation in the three-dimensional coordinate system, and this is equivalent to 23 in the two-dimensional coordinate system. So how about if we replace 0 by 4? Okay, you see